So now we're going to be dividing polynomials, which is very similar to dividing numbers using long division. So how does division relate to multiplication? Well, let's say you have the numbers 3 and 4. 3 and 4 are called factors of 12 because 3 times 4 will give me 12. So remember when we did our unit on factoring, let's say I gave you this polynomial and I asked you to factor it, we're looking for the two binomials that will multiply together to give me the original. So x minus 1 and x plus 1. So when things are factors, they're going to be multiplied to give you the original thing. Okay, so let's say we have the number 36. And we know that 9 is one of the factors of 36. So what is the other factor of 36 that when multiplied by 9 will give me 36? Well, 4 times 9 gives me 36, right? Now, if I didn't know that off the top of my head, I could still do 36 divided by 9 to find the other factor. So division will help me find factors also. So what if the numbers don't go in evenly? So let's say we have the number 42 and we divide it by 8 to see if 8's a factor. Well, when you divide 42 by 8, you're going to get 5 with a remainder. Okay, now remember, remainder, we don't leave it R2, remainder 2. What this remainder means is you take the remainder, you put it over what you're dividing by, and you add what you got when you divide it. So 5 plus 2 over 8, which is going to simplify to 5.25. So 42 divided by 8 gives me 5.25. Therefore, when I multiply 8 times 5.25, I should get 42. So division and multiplication are inverse operations of each other. So do you think that 8's a factor of 42? No, because it doesn't go in evenly, right? So the definition of being a factor is one of two or more quantities that divides a given quantity without a remainder. So that's the biggest deal. We cannot have a remainder if things are going to be factors. So here is some basic vocabulary that we need to review when it comes to long division. So underneath the division bar, we have our dividend. What we're dividing by is our divisor. What we end up getting is our quotient. And then what's left over is the remainder. Now remember, we don't leave it as R something. We want to know what that actually means. So when we do 271 and we divide it by 4, what we get is 67 plus you do the remainder over your divisor. So 67 plus 3/4. And we could also write this as a decimal, and that is 67.75. So everything we just did is going to be related to dividing polynomials. So let's say I have 2x squared and I want to know, is x a factor of that? Well, you divide to figure it out. So 2x squared divided by x can be seen in a few different ways, right? So we can write it with the division bar, or we can write it with the fraction bar here. So dividing that, we would get, well, the bottom degree is 1. Therefore, we're going to be left with just 2x. Now over here, think about this. How many times does x go into 2x squared? Well, it goes in 2x times, right? So 2x times x is 2x squared. You subtract and you get 0. So that means 0 remainder means that x is a factor of 2x squared. And if I were to write this, 2x times x gives me 2x squared. So these two are the factors of 2x squared. So this compares long division of numbers to long division of polynomials. So we still have our number on the inside, or our polynomial on the inside. We have what we're dividing by, our divisor, and we're going to have a polynomial that's our divisor. We're going to end up with a quotient that is also going to be a polynomial, and then a remainder that will be a polynomial. So that's why you see these of x, because these are all going to be different polynomial functions. So here you can see how we relate division of numbers to division of polynomials, right? So we have our divisor, d of x, our quotient, q of x, our polynomial function, p of x, and then our remainder, r of x. Now when we actually do the division, our answer is going to be our quotient, q of x, plus, now remember what we did before, we took our remainder and we put it over our divisor, so that's exactly what we're going to do. Q of x plus r of x over d of x, and that's going to be our final answer. Now, if we do not have a remainder, then we just have q of x as our answer, which means that the polynomial p of x is d of x, our divisor, times our quotient q of x, all right? And d of x and q of x would be factors of p of x. Now, I know that's a lot of vocabulary, but if you look at it, it's exactly how things go when you divide numbers. So when we divide polynomial functions, you must be in standard form. Your dividend and your divisor need to be in standard form. So what that means is that we might be missing terms that we have to include with zero coefficients. So take a look here, 4x cubed plus 2. I'm missing the quadratic term and I'm missing the linear term. So I have to go through and put those terms in, but with zero coefficients. So I'm not changing the value, but I'm having it as a placeholder. So you need these placeholders whenever you are going to be dividing. Now, when we're dividing polynomial functions, we know we stop when the remainder is less than the degree of the divisor. All right? And that will become more obvious once we do some practice problems. So when we're dividing polynomial functions, I want you to recall how you divide normal numbers using long division. So let's say you had 63 divided by 2. Well, you would ask yourself, how many times does 2 go into 6? Or what is 6 divided by 2? Well, that's 3. So we put that up top. Then we would multiply 3 times 2, which gives me 6. And you would subtract. So 0, and then you'd bring down what's left, right? 3. And then you would do the same process again. How many times does 2 go into 3? Well, that's 1 time evenly. And then you would do 1 times 2, which gives me 2. And then you would subtract 1. Now, 1 is smaller than 2, so you know you'd stop. You're not going to be dividing anymore unless you want to do placeholders. And then you would write it 31 plus the remainder over the divisor, which is also 31.5. So the same steps we did there is what we're going to do with polynomials. So we look at our divisor, we look at our dividend. We want to make sure when we divide, we line everything up. So 4x squared and x. What do I need to multiply x by to get 4x squared? Or you could think 4x squared divided by x, what do you get? Well, that's going to be 4x. And I'm going to line it up over top the linear term underneath the dividing bar. Okay, so now we have to multiply back 4x times our divisor. Now our entire divisor, so you're going to do times x and times 5. So this is the part that's a little bit different. So 4x times x gives me 4x squared. 4x times 5 gives me positive 20x. And then you subtract, just like we did with the long division. So subtracting, you should always get 0 here. You need to get 0 here. If you don't get 0 here, then you did not get the correct term up here. Okay, so you should always get 0 here. And then subtracting, remember 23x minus 20x. So always go back to this minus out here. Gives me 3x. And then you bring down what's left. Now we're going to keep going, right? Because now the degrees are the same. We want to stop when the degree down here is smaller. So what do I need to multiply x by to get 3x? Or what is 3x divided by x? Well, that is 3. Notice how this constant term is lining up over top the constant term underneath. And then I take the constant term 3 and I multiply it times each term. So 3 times x gives me 3x. 3 times 5 gives me positive 15. And then I subtract. So make sure you're always going back to the subtraction bar. So 3x minus 3x is 0. Negative 16 minus 15 will give me negative 31. So then there we go. The degree of this guy is smaller than the degree of our divisor. The degree of the constant is 0. The degree up here is 1. So I know that I'm done. So what is my final answer going to look like? Well, when I divide, I get 4x plus 3. And then I take my remainder and I put it over my divisor. So this would be my final answer. So if I asked you, is x plus 5 a factor of this? No, it is not, because I got a remainder. So now we want to check to see, is x squared plus 1 a factor of 3x to the 4th minus 4x cubed plus 12x squared plus 5? Now, what does that mean? That means when I divide them, do I get 0 as a remainder? So remember, we always want things in standard form. So x squared plus 1 is missing that linear term, so I'm going to go ahead and write in the linear term. Now 3x to the 4th minus 4x cubed plus 12x squared Now I'm missing the linear term, so I'm going to write 0x plus 5. So now we go through the process of dividing again. So what do we need to multiply x squared by to get 3x to the fourth? Or 3x to the fourth divided by x squared, what do I get? Well, when I divide those, I'm going to get just 3x squared. So since it's a 3x squared, I'm going to write it above the squared term underneath. So then I multiply back through. 3x squared times each of these. So 3x squared times x squared gives me 3x to the fourth. Notice how those line up perfectly. 3x squared times 0x, well, anything times 0 is 0, so that's going to give me a 0x cubed. And then 3x squared times 1 gives me 3x squared. And then I subtract, right? So everything needs to subtract. If you want to put parentheses here to kind of remind yourself of that, go ahead and do that. So 3x to the fourth minus 3x to the fourth gives me 0. Negative 4x cubed minus 0x to the third is negative 4x cubed. 12x squared minus 3x squared gives me positive 9x squared, right? And then we bring down the next term. And then we start over. What do I need to multiply x squared by to get negative 4x cubed? Well, if I divide those, I'm going to get negative 4x. So negative 4x. Notice how it lines up with the linear term underneath. And then I'm going to multiply back through. So it's going to go to every term once again. So negative 4x times x squared gives me negative 4x cubed. Negative 4x times 0x should give me 0x squared. Negative 4x times 1 gives me negative 4x. And then I subtract. Now, don't get tripped up with the signs here. It's very easily to mess up with the signs here. So negative 4x cubed minus negative 4x cubed. Remember, minus minus same as addition. So that's 0 again, which we should always get. 9x squared minus 0x squared is just positive 9x squared. 0x minus negative 4x, okay? So the minus and a minus will give me plus. And then I bring down the term, right? And then I keep going. Notice how the degrees are the same now, so I still need to keep going. So how many times is x squared going to 9x squared? Well, that's 9 times. Multiplying that back, I get 9x squared plus 0x plus 9. And then I subtract. So subtracting these, 0, I'm going to get plus 4x. 5 minus 9 gives me negative 4. And now you can see that the degree of what's left is smaller than the degree of the divisor, so I know that I'm done. So final answer here, if I was dividing it, would be 3x squared minus 4x plus 9. Then you would take the remainder, 4x minus 4, put it over the divisor, which remember was just plus 1. We don't have to write the 0x. And that would be the quotient. Now, the question was, is it a factor? Now, the answer is no, it's not, because I got a remainder. All right? But if it was, you'd be able to take the quotient, multiply it times the divisor, and those two multiplied would give you what you originally started with. So if it is a factor, you want to be able to show that you can take those two factors and multiply to get the original function. So now I want you to try these examples. Example 1 and 2 are not going to need any placeholders because they're in standard form and they're not missing any terms. Example 3, you're going to need lots of placeholders for x to the 5th minus 32. So make sure you do that. You need 0 x to the 4th, you need 0 x cubed, and so forth. Now, if you need more examples to help you do these problems, you can use your book as a resource. This is section 5.4. Or you can go ahead and Google dividing polynomials and you'd get a million different resources. Go ahead and write your answers in your Google form. Remember to use the caret symbol anytime you want to insert an exponent.